Well, everybody, welcome and thank you for joining this webinar on Dynamic ESS. My name is Johannes Boonstra. For the people who don't know me, I'm primarily involved in sales. And I'm sitting here together with Dirk-Jan Faber. Well,
Dirk-Jan Faber, software developer at Victron.
So if there's difficult questions, then I'm sure that Dirk-Jan will be able to answer them. Let's see. The goal of this webinar is to prepare you for advising for you and for end users what may come on the field of Dynamic ESS. I think a lot of people already are thinking about what will happen in the future on storage systems and on self-consumption systems. And I think this feature will also be some of the things that a lot of people will inquire about. So we would like to tell you already what we have been done on this field on Dynamic ESS, how it works, and how you can advise your clientele with this. The topics. Basically, there are 4 topics what we're going to do today. The first one is what is Dynamic ESS? Why is it there and what does it do? But also to explain the logic behind it, so that you know why is it making the certain decisions that it's doing. Of course, also, what do you need hardware-wise, battery, communication, inverter, and so on. And also, of course, how to set it up. It's already able to be used at this moment. It is in a beta version, so it's not completely finished yet, but you already can try it out and see how it works for you. Well, going one step back for Dynamic ESS is basically, what is self-consumption and what is an ESS system? Well, typically, if you have solar panels or other renewables in your system, you have something like this. So you have the grid on one side and you have your loads, and your renewables generate as much power as they can. And independent of your load, they're working maximally. So that means that the energy will go through your loads, so you have your renewables used for your own system, and every surplus what you have will automatically flow into the grid. If you have an ESS, a self-consumption system, basically what you do is optimize that flow of energy. So what you can do then, by measuring the energy towards your grid or from your grid, you can decide what you want to do with this energy. So typically, the goal of the system is then to prevent feeding energy to your grid and also prevent buying energy from the grid. So each time the system would normally typically go to feed in, it would then charge your batteries. And as soon as the system requires more energy than you have from your renewable, you will discharge your battery. So you use as much of the free self-generated energy as possible. If you do that, if you have a system, it's necessary that you measure in your AC distribution what your energy flow is. So where the energy is going and what the amount of energy is. Well, we have a few solutions for that. You can see the list here. It depends on which maximum power they can handle, but also the way they communicate with the system. So one is with Ethernet, the other one is with a serial cable with a 485 signal. One is for 3-phase, one is for single phase. So it depends on, per model, basically, how you do that. But it's necessary that you have your energy meter in your system, because then the system also knows what the energy flow is and also what the values is. If you connect that to a GX device, typically you use a serial cable, 485 to USB. And that means then that the servo or the other GX device knows what the energy flow of your system is. So I think most of you already have done this once, but this is also for any energy system it's needed to have. If you have that energy meter installed, well, basically what you do then is find that system in your device list and then give that system, that energy meter, a role. For a grid meter, of course, you choose a role as grid meter, and then from then on, the system can work with this. By the way, I forgot to mention that actually. If you have any questions, I have some colleagues also online working as host. That's Bob Hopman and Leo Intema. So if you have any questions, they will also answer these questions into the chat box. So if you have anything to ask, please use the chat box for that.
Colleague Alex Imbria is also online
Okay,
for
yeah,
that,
yeah, true.
for the
Yeah.
more technical questions, I suppose.
Yeah. Well, to go through these systems a little bit fast, you have different kind of renewable system. You can have a DC coupled system. That means that you charge your batteries directly from your renewables, in this case with an MPPT charge controllers. Typically, when you have a system on the majority charging your batteries, that's where your efficiency optimum lies. Then a DC coupled system is used often when you have also systems which have a lot of AC load used directly while generating. Then you also have the option to do that with an AC coupling system. Basically, both of the systems can work with ESS and can also work with Dynamic ESS. So, you have the option to choose which system you want. And basically, for the system itself, it doesn't really matter. But you have the option to do both. Also, of course, the combination is possible. If you have AC coupled and DC coupled in one system, on AC input or AC output, all the variations are possible. Well, Dynamic ESS use cases. Well, to have a Dynamic ESS is basically an add-on to the self-consumption system that you have. And what does Dynamic ESS do? Is basically there are two use cases. The first one is that you have the day-ahead prices. In Europe, the day-ahead prices are being broadcasted by an organization, and that organization gives the day-ahead prices basically every day around 3, and then you know exactly what the price will be for the coming day. But you also areas where you have a fixed pricing for day and night, or for weekdays, or for weekend tariffs, just like the Economy 7 in the UK. Dynamic ESS also works for that area, so it can do both of these price structures. If you go to the website of NSOA, that's the website which is giving you all the detail, you can see per country what the price level of that day is. You can click on the country, and then you can see in a graph per hour what the price difference is. And even for some countries, you have different price structures per area. If you look at, for instance, for Italy, you have about 5 or 6 different areas, but also Norway have that. So if you implement Dynamic ESS and you have to make the settings, and Dirk-Jan will show you later how to do that, but you can also choose which area in the country you are based, so that the specific prices are being used for your area. What does Dynamic ESS logic-wise do? Well, basically what it does, it's getting the prices, the fixed prices are from the AP, from the website, and it does that automatically. So in the VRM side, what we show you later, you will fill in which area you are, and then the AP of this VRM will each day get the net prices of your for your system. With that, also you have to find what is your energy provider fee. So let's say the margin what your energy provider puts on the cost of energy, and also the cycle cost of your battery. The system works with your energy meter, also with a load profile of your system, so it has a forecast of what your system is doing. And also that's happening on solar, so it's also seeing what the renewables are doing day by day. And by telling the location of your system, the system can also predict the irradiation in your area. So it can also predict then what the renewables will generate. Well, on the right here, you see a small graph, and that's basically from an energy provider from the Netherlands, from ANWB, and you can see the cost price of the energy hour per day. And basically, like I said earlier, 3 o'clock in the afternoon, the broadcasting of the next day will be done. So you can see then also what the price will be, and the system then will make a plan on how to use that energy as optimal as possible. So it knows what is the best to feed in your energy, or what is the best to buy your energy.
Yeah, now for a little bit more technical details on that. As said by Johannes, the new prices get in at 3 o'clock in the afternoon. So earlier in the day, as soon as the new prices get in, the algorithm can start working with that. So it calculates hourly optimal state of charge, which is called the target state of charge, which it will try to get within that hour. The system schedules 4 hours in advance. So if the network gets lost, the network connection is gone, then it will still continue functional. In order to set the system up, VRM will insert the schedule into your GX device. So therefore, it needs two-way communication. Also, as said, new calculations are done every hour, and in VRM you can configure your system. As soon as you change your system configuration, it will take 1 or 2 minutes, and then the new calculations will be done according to the new configuration. That's up to 5 times an hour for configuration changes. So that's one thing to keep in mind. In order to reach your target SOC within the hour, it uses the maximum power, which you will need to configure, but we'll see that a bit later on. It uses the forecast solar production, expected consumption, and which the expected consumption is based on your previous 28 days of consumption. And it uses the buyer price, sell prices to determine when to charge and when to discharge. And it takes the full hour to reach that target SOC. So it's not going to charge within, sometimes it seems that it's only charging slowly, but that's because it wants to reach the target slowly. Mm-hmm. Yeah. On the VRM portal, you will get to see the price graphs, which we could already show them, or we'll
we go to the
we go to the slide
website,
and then we go to the VRM website, which we'll dig in a bit deeper to that. You'll see the energy price. Well, each hour the price change, and on the lower graph you see the battery consumption and the grid consumption, or what it is feeding back into the system. You also get to see the energy graph, which is a which says how many what your costs are per hour. If your battery also using your battery will cost some money, because every kilowatt hour which goes through it costs a few cents, and that, well, that's also shown in this graph. With this graph, which is not yet in beta VRM, but it will be, and some people might already know it from the Node-RED implementation, we'll also have quite a complex graph, at least at first sight. It shows what the system is planning to do, and it shows what the system has done so far. The vertical line will be the hour. So Johannes took this screenshot at 9 o'clock in the evening, and everything before that, it shows what the system did. So it either charged to grid, it's charged to the batteries, the solar production is shown in this graph. Yeah, so that makes you can really see what the system has done. always note that it uses forecasts, which may be a bit off in some cases, but the left side of the graph is always what the system has done, and the right side is what the system is planning to do.
Basically, what the system is doing is it's making a plan based on the information that it has. It says, well, this is the most optimal way, financially then, to use that system. What I've written here is well, to explain the main difference between ESS and dynamic ESS. And basically what ESS, so the self-consumption system, does is that it has the surplus energy, which your renewables generate, and it's being stored in the batteries for later use. So basically the goal is to minimize the grid usage independent of the energy tariff. So it doesn't matter what the energy cost. The goal is to use as many energy what you generated for yourself. So basically, if you have a surplus during midday, then that energy will be stored in the battery and you will be able to use that later that day. That means you don't have to buy and you don't have to sell energy, which is most of the times the most cost effective. Dynamic ESS is an add-on to that to build an extra business case on a self-consumption system. And that is making a plan, not so much on well, when to use that energy, but when to sell and when to buy energy from the grid, depending on a higher tariff of energy. So it can well be that while you're feeding back energy actively in the middle of the night because the energy prices are higher than during the day. So it's more a trade system. So you buy and sell energy into the grid than what ESS is doing. ESS is just well, using the same energy what you generated on a later moment, and dynamic ESS is making a plan on when to inject energy into the grid or when to buy. And that's well, a huge difference. Dynamic ESS will aim for basically less average cost by choosing when to feed in renewables. So it tries to optimize well, what the cost and what your gains of your energy price is. And also, of course, trade energy to buy low and sell high. So it can also actively buy energy from the grid at the moment that the prices are low. And on a later moment when the prices go up, it can decide to sell that again. So that's something what ESS is not doing, but dynamic ESS can do for you. Well, what do you need? Well, basically, if you have a system, you need to have a GX device. A GX device such as a servo GX, and that servo will then act as the main part of your system. The calculations and the communication are being handled by that servo GX. So it's essential that you have a GX device in your system. And of course, besides that, you need a multi-plus, you need an MPPT charge controller, and most likely also a managed battery. You can do it also with other batteries, but the managed batteries work optimal, of course. As far as inverter chargers, you can use all models, all VE bus models, multi-plus 2. Basically, the complete power range is able to work for ESS and for dynamic ESS. That also goes for 3-phase and single-phase. The way the system is set up is not relevant. In this picture, you see the Easy Solar GX, and then you don't need a separate GX device, but the GX device is already built in, and also the MPPT, of course. What you also need is a stable grid connection, because you have to depend on well, the grid to supply you energy, and you have to be able to feed in the energy back into the grid. That means your grid has to be stable. If you have a very unstable grid, then the system is not able to draw energy and push in energy at the right circumstances. So that's something you definitely need. Dynamic ESS and ESS systems in general are not possible when you're off grid because, well, quite logically, there is nothing to sell or to buy, of course. When you have an automotive or marine system, so basically when you have a system connected by a shore cord, and also when you have a grid which is very bad. That very bad can be voltage-wise, but also independent, that it fails every now and then. You need to have, well, like I said before, you have to have a stable grid. Theoretically, dynamic ESS does not need renewables. Buying and selling can be done without having a solar system or a wind system. Most likely, business case-wise likely, it's more that dynamic ESS will be used on systems where you have renewables to build the extra business case. Having dynamic ESS without renewables, well, is critical on the business case side, so to say. But theoretically, it doesn't need to have renewables to be working. The battery bank, well, most likely you're going to go for lithium, because lithium is basically the battery with the highest runaround efficiency. That means you lose as little as possible energy. Other batteries theoretically can be done, but well, it's advised to go for a lithium battery. And then, of course, if you choose for lithium batteries, choose for the managed batteries, because the managed batteries are much easier to well, communicate with, and also the simplicity and cost has a big advantage on that side. How to make dynamic ESS settings? Well, this is a screenshot from my system. Well, Dejan, you can.
Let's go to the system.
Yeah.
I'm not sure. No, this is not shared. Let's see how to share the screen. A moment.
Rechts.
Rechts.
Groen.
Is this? No, it's sharing the wrong side. One moment. Let's see how to do it. Then I need to share the Safari. Yeah, that's it. We're now on beta VRM. You can already use this and test this if you want. It's going to be on VRM at a later moment. In order to activate Dynamic ESS, you can go to Settings, and you find the new Dynamic ESS option. Johannes' site already had it configured, but we'll go to the first step where you normally go to. You need to fill out a questionnaire in order to set up Dynamic ESS. It's just well, 5 steps. Then the system first needs to know the limitations of your grid connection, or well, of your weakest link, to say, in order to not overheat any.
In my case, it's fairly low, because my system is in a small shed outside my house, and there is a small cable from the AC distribution to that shed. That means I'm limited in the amount of power that I can import or export. So that's why it's mine is limited at 10 amps. So that's why it's set on 2.5 kilowatts.
Yeah, and the first question is whether you can sell back to the grid or not, because in the Netherlands you can, but in some countries it's not allowed. It all depends on your energy contract which you have.
Yeah.
Well, then you can go to the next step. Then it needs to know some information about the battery. First of all, it's the battery capacity. This capacity number is used for calculating how many what the amount of kilowatt hours is in 1% of SOC. So if we have a target SOC and we have a current SOC, we know how many kilowatt hours we have to charge or discharge the battery within an hour. We aim to do that in, say, 50 minutes till an hour. So it's not going at top speed. Then you need to fill out the maximum discharge power, maximum charge power, and the battery costs. Battery costs are typically around 4 cents.
I will show you a calculation later on to show this.
Then you need to say the minimum SOC, unless the grid fails. That's the value that the Dynamic ESS won't go below. So you have some room for self-consumption left. Then you can go to the next step. That's for the buy prices. In the Netherlands and in a lot of other countries, all these NSOE countries which we showed before have dynamic prices. You need to have an energy provider which which provides that. And so it means that you need to select your country. Now, Johannes is based in the Netherlands. But if you, for say, have Norway, which has these different areas, then you get some extra bidding zones. And the same goes for Italy and Sweden. At the moment, we don't have that many providers in the list yet, because every provider uses its own formula for calculating the buy and the sell prices. We are building up this list, and new providers will get added soon. Johannes' provider is not in the list. It's called AOEB, and Johannes had to fill out his own formula. This is the formula. You can build it up by adding or adjusting this formula, so you can get some extra, say, extra numbers in. But typically it's called, this is the 3 cents, which is added on top of the energy price by the provider. Then it's oh, I see a question that it's no, it's not taking into account that the price differs during the day, the provider fee. Not yet, at least. Keep in mind that we are running this as beta right now, and new additions will be done. We get this for the big majority first, and then we add except minor, less important cases.
Yeah.
Well, 3 cents is the provider fee, then the 30 cents is the transport fee, and then the taxes, that's which is 21% in the Netherlands, so we need to multiply it. New formulas will be added, and there's also a community formula post where you can get some ideas on if you don't know your formula. Then we go to the, also if you did not have dynamic pricing, you could go to fixed, which is for the UK, and well, in the Netherlands, there's also providers which have fixed pricing. You can add, say, the time and set the price on from which time till which time you have a certain price for your energy. At the moment, this is only fixed to hours, but we'll add it at half hours, because UK providers have it in half hours, I heard yesterday. So we'll add that as well. We can go to the next step. I already did sell prices. Well, sell prices is basically the same as the buy prices, but usually the formula is instead of plus, it's a minus. The sell prices, it's a plus, and buy prices, it's a minus in right here. After you filled out the complete form, you get to the confirmation, which is a summary of all the things you filled out. And if you need to adjust it, then you can go to the edit button, and then you can adjust it. If you hit submit, you get a message that you've successfully configured Dynamic ESS. You can go to the dashboard of your site. Hold on. To the dashboard, and then in the controls, you get the ESS, Dynamic ESS, the Dynamic ESS, which is set to auto. Auto is the default and the recommended setting for Dynamic ESS. If you see real low prices and the system did not decide to charge, you can press this buy button, and then the system will start buying energy from the grid, and the same goes for sell. And with the off button, you can switch it off. Dynamic ESS off. And you can also adjust the minimum SOC setting from this control. Then if you go below, you have 3 tabs here. I see that energy tab just got in. The first tab shows costs and earnings. We'll make a good summary here. It was here before, but the calculation was a bit off. So we're working on fixing that. You can see here per hour, Johannes made some grid costs during the night for his consumption. Here he made grid earnings and some battery costs. So the battery discharged into the grid here. Then he bought a little bit back from the grid. It's predicting, and then we go to the current hour, set to 11 still. And then on the right side, you see the forecast of the plan, what the system is intending to do. So it's going to make some earnings today.
That's good.
That's good. The second tab is the schedule. You also see the prices in the Netherlands. That there was a peak here, and we just saw on that on that peak he delivered back to the grid.
Yeah.
So for a high price, and it would start earning a bit later. So it's probably on the peak as well.
I see that Alex wants to add something to the conversation. Alex, do you want to share something?
So I wanted to share that if you go to a different site, namely Harold's site, you can see some actual costs and earnings. So I think it's better to show them there. It's also a bigger site, so you
I don't have that side.
more data.
Oh yeah, but Johannes does not have that side, so that's
Okay.
that's
I'll
impossible
continue
to
with
show right now. But
We can do that later if needed. Then that's
we can share some screenshots later on.
Yeah. We will see if we can add that side to my list, but at the moment we don't have it in. But we can show that later on if
Then below the schedule, you can see the usage. Well, we saw just that the system fed back to the grid. So it fed back to, well, this is so in kilowatt hours, how much it fed back and how much the battery was used. And well, the plan is also there. And then the last step is loading.
well, what you can see in the system is that it's working on a plan. It's predicting what will happen price-wise and energy-wise, and then it rolls out a plan how to handle it and then actively control when to feed in and when to buy.
Yeah, well, the energy graph is not loading right now,
No.
so that's the demo effect, I suppose.
I think that it's now in my list to go to Harold's.
Okay, and then
go back. No, you can go.
Yeah. I know the number by heart.
It's already there.
8723 is the
Oh,
number.
there, yeah, there.
Yes.
Does it load?
Load.
Yeah.
Yeah. Then I need to move this bit. So. Harold system is also running this Dynamic ESS. And he has the energy tab there as well. So we can see this graph. This is what it done. Harold does own an EV car. Yeah. So he really charged his car there. The system does not account for, well, it does account for what it what your previous consumption was, but it does not know exactly when you will charge your car.
Charging a car is also an extreme high energy need for your system. So it's also very difficult to predict and to handle charging your car, because it's also not known, well, what will you do with your car and how much will you drive in a certain period. So implementing the EV charge into Dynamic ESS is kind of hard and also not done yet.
No, we are contemplating on a way to add it, but it's not there yet. But it's going to be there in the future. Yeah. This site also has the earnings with Dynamic ESS and the earnings without Dynamic ESS filled out. In first glance, it looks like without it's more beneficial, but if you look a bit closer, this is what it the earnings without is what it predicts for the whole day, and the earnings with is so far. So far it did cost
better.
Yeah, 98 cents, but it forecasts that you will go to €5.80 at profit.
Which is substantial.
Which is substantial. And might add that Harold does have a big battery, I think 55 kilowatt hours.
Much bigger than mine.
Yeah. Yeah, I think that concludes the demo here. Let's
Is it active sell and buying?
Did I? Yeah, this is.
Do that? Okay.
Yep. Yeah, on our Node-RED implementation, we also show the target SoC in the graph. That will come in the VRM version as well, but it's not there yet. But it's going to be added.
For the people who don't know that yet, we have trying Dynamic ESS out with Node-RED, and Node-RED was just a chart flow of how the system works, how the algorithm can be set up, and so on. That's how we learned how the Dynamic ESS should make that plan. And now since a few days, that's been migrated to the beta VRM side. So now you don't need the Node-RED flows anymore. It's directly coming from the VRM side.
It's not to say that the Node-RED implementation will still get further development as well, and you can use either one, not both at the same time. Yeah. But there is documentation on how to set up the other way.
Yeah.
On the GX device, how does it look? On the GUI, you can go via the ESS menu. You can go to the Dynamic ESS setting. You can see that it's set to auto. You can see already here the target SoC, what it wants to reach within that hour, and this changes hourly. And you can see your minimum SoC setting. And you can alter it as well. Let's see. This is the regular ESS setting, which you already know.
This is the ESS menu where you can find the Dynamic ESS setting in.
Yeah, I think it's lowest in the list, the last one in the list.
Well, one thing is good to add on this is that typically when you have lithium batteries used, you use the battery life feature. That means that the amount of energy what you use from your battery is depending on the energy that you're able to recharge that battery with. So in order to keep the battery as full as possible, the system changes the lower state of charge setting to power that up each day to prevent that your battery becomes working in a lower state of charge. When you have a Dynamic ESS system, I found out that it's better to switch that off, because you want to use the whole energy of your battery, and you don't want to have the system interfering on the amount of energy that you can use from your battery. So most likely with Dynamic ESS, you should switch with battery life off and just use it uncontrolled, so to say. So you use the whole state of charge, undependent on how much renewables you have. So, well, doing the calculation, that's of course always a tricky one, because there are so many variables in this, and it's also, well, different for a lot of countries and for a lot of energy providers. So it's just a rough thing, what I will go through. Basically, if you buy a system, you have a certain amount of investment. Well, in my case, it looks like about this. So 15 kilowatts of lithium, a 5 kilowatt inverter, an energy meter, turbo, and everything what comes along. And that is about an 8,000 euros of investment. So with that, you can calculate what your system cost is, because of course, if you add an energy system in your AC system, that means that you also have a write-off of that energy system, and the system earnings must make up for the cost that you have made. So typically, I've made a calculation on what my battery would cost per kilowatt hour that I use it. So in this case, I said, well, my battery is about 6,000 euros. The number of cycles that it can do is about 10,000. That's of course also a rough estimate. And if I divide that then by the capacity that the battery has, 15 kilowatt hour actually, then the price is about 4 cents per used kilowatt hour. So this value has been filled in the VRM website. So the VRM website and the Dynamic ESS knows what the cost of that battery is, and can also decide, well, if the costs are too high compared to what the money is, what you can make from it, it decides not to use the battery. So only when you come over a certain amount of benefit of your battery, then it will use it. Well, if you look at the estimate cost reduction when you use Dynamic ESS, well, in this case, I said, well, on average, what I see in my system at least is about a 20% cost reduction per kilowatt hour, and then times the 15 kilowatt hour that my battery does is about 3 euros. But it depends, of course, heavily also on the time of year, because, well, in the summertime is different than in the winter, also for well, different areas that you can be in. So basically, the Dynamic ESS is help building your business case when you already have an energy system in place. So when you have an ESS or you have another application for your batteries, then running also on top of that, the Dynamic ESS helps building that business case. So having the Dynamic ESS on its own, well, then it's going to be tight critical, depending on where you are, of course, but it helps making the business case better if you add it onto an existing system.
Also, what Johannes noted, just that it performs better in summer as in winter, probably, is because, well, we get the prices in at 3 o'clock in the afternoon. There's at that moment in the summer, there's still more solar production of the day left to make adjustments in the calculations.
You have longer days.
You have longer days, so that makes it easier to adjust for the system. And as always, well, in hindsight, it's always easy to look at your calculation. Well, the system made an error there, but if you only use forecasting, then it's probably then it's more tough.
Yeah. What are the unique selling points for a for a Dynamic ESS system? Well, first of all, if you go for a Victron Dynamic ESS system, there's no subscription needed. So if you're having a GX device connected to the VRM website, you can just, well, activate Dynamic ESS, and it's free of charge. You can configure it yourself, so you can choose which cost you have, which area you have, which formula you have. So it's all, well, able to be done by yourself. And it's adapting also to your load profile. So by using the energy meter to determine what your load profile of your system is, it can improve also the plan that it makes for the energy usage. It can work without solar or wind. Of course, like I said earlier, I think the business case is better that you add it on an existing system, but theoretically it could do that. And basically, it decreases the overall energy cost by optimizing the energy uses, but also to, well, buy and sell energy to the grid and from the grid.
Yeah, it's in the long run, so it's not, well, it may make an error every once once in a while, but in the long run, it saves your energy cost.
Yeah, Dynamic ESS,
Yeah.
I think that's what you try to say, is
Yeah.
making a plan, and that plan is not always perfect, but it's the best it can do. So we will try to make that planning more and more optimal, of course. But
if you decide to say charge your car or something else, the system could not predict that. So
and you could have done it wrong. The system
yeah,
correct. Yeah. Well, for who is Dynamic ESS basically a good idea? Well, what we see up to now is basically that a lot of people are interested, and these people are wanting to be in control of their own energy. They say, well, I don't want to be hooked on an energy company that they decide what I will do and what I have to pay, but I want to be in control for myself. So they want to be autonomous energy-wise. So they want to be using the energy when they want or supplying the energy when they need. Also, users that have a no-break system for critical loads already in place. So they already have batteries installed. And with Dynamic ESS, they can make good use of that battery. So they can do extra features with that battery to make a business case. And that's, of course, also the trading energy. Also, a lot of people want to promote sustainability because in the end, Dynamic ESS is, of course, good for the energy provider and also for the environment in total, because you balance out the grid better. So the usage of renewables on an energy grid is being more optimal handled by Dynamic ESS in that system. So if you want to, support that, then also Dynamic ESS is something you could do. And also, of course, like I already said, contributes actively to that grid balancing. So making uses of energy more stable and more better also for the long run.
Yeah, prices are high, so you help the system by providing the system, the grid, but with your solar yields.
Yeah. So you're helping yourself and you're helping the grid and you're helping the environment. Of course, for people who we talk to on Dynamic ESS, they say, well, what if I want to control other devices? Well, at the moment, the Dynamic ESS system, what we have now, is not able to control your heat pump or your EV charger or something else. But of course, you can make that. You can make that by using a Node-RED chart flow, or you can use relays, or you can make something with Modbus. Most likely in the future, things will be added on the VRM side that you can do these things, but for the moment, not. We have now this stage, this making of plans for Dynamic ESS, and that's what it is at the moment. Things will happen in the future, but at the moment, you cannot control when to charge your electric car or when to start or stop your heat pump. But of course, again, if you have experience with Node-RED, you are able to do that.
Oh yeah, just before we start here, when can we expect this on VRM, which will probably be somewhere in October?
Yeah, at the moment, sorry.
Yeah, we're still beta testing, get some last child diseases out, I'd call them. And if it's stable and good for working properly for a while, then we'll...
So it is still beta, so don't be surprised that things are not completely perfect, but it's worked on and it will get there. And like you said, in October it will be migrated to the normal working VRM side.
Yeah, there's a plan on community forum. We have a post on it. So if there's remarks, questions, or other issues, then please go to there. Yeah. Okay, now I go to your promotion.
Now my favorite part. We have, besides this, also a promotion. And the promotion is primarily for ESS systems. And the promotion is two-sided. We have two types of promotion. One is that if you buy a 3 or a 5K multi+2, you get a GX, a Turbo GX, free of charge. So there's a nice incentive for ESS users. But also, if you have a 3-phase system, so you need 3 of the units, then it's even a more attractive promotion. If you buy 2 of those units, you will get 3. So one of the units is free of charge. This promotion will start the 1st of October and will end the end of the year. So if you're doing something on the ESS systems, please take advantage of this promotion, because I think it's quite unique, and it can well be worth it to convince people to go for a Victron Energy self-consumption system. I hope you found this interesting. I hope we explained it to everything that you needed to know.
Yeah.
If there are questions, I think this is the time to do it. We will be able to answer some questions now. I'm not sure how long we take for this, but yeah, if there's questions, let us know. So,
And it's also in the Q&A, you can just fill
Yeah.
out the questions, which will be, I already said, see that 142 questions have been answered. It's possible to get day-ahead prices from Nord Pool as well. I think Nord Pool already gets its own prices from ENSO-E. So the prices are the same, if I recall correctly. Is it possible to use inverter charges when it's required a higher power?
yeah, you can make every system you want. You can make a single phase, parallel, three-phase, parallel with three-phase again. So basically, you can build the power requirement that you need.
Yeah, I see a question whether or not dynamic ESS is only possible in Europe or also in other parts of the world. Well, the dynamic part and the dynamic pricing hourly changing tariffs, as far as we know, are only available in Europe. That being said, you can also set the fixed prices, which you can, if you have hourly changing prices but fixed, then you can also fill it out in the portal. And if you have different weekend or week prices or evening and day prices, you can use Dynamic ESS for that. But then you have to use the fixed tariff. Will it support virtual batteries added to the Victron system battery?
I'm not sure what
a virtual battery is.
No, to be honest, I don't.
So no real plan for it, I suppose, but if it's interesting, then it will probably be added. But we need some more context for that.
Yeah, one more.
Here, yes, that.
I missed the part of the equipment needed. Is it possible to make a three-phase dynamic ESS system with Victron Quattros or 50Ks? Yes, that is possible. All the multis, but also Quattros, of course, can be used for an ESS system, and therefore can also be used for a dynamic ESS system.
Just seen the advanced energy price graph shown earlier in the presentation now appears on the beta VRM page. Yeah, it just got released, I think, during the webinar.
Yeah.
So that's it was not there yesterday, but today it is. So that's good. We're still working on it, further developing it, and there's new graphs coming with the target SoC showing as well. So you see the plan.
It's nice to see what the system is going to do.
In
order to understand what's happening.
We noticed that a lot of people like the idea, just to see in advance what is the system planning based on its information.
Correct.
Thank you. Do you plan to involve EV chargers to the system? Yes, we will. We are planning that, but it's in the early stages right now. So it's going to take a little longer before we get to see that. You need test guys.
Well, you can already test for yourself.
Can already test for yourself and provide feedback via the community forum, which is probably helping other people as well.
Mm-hmm.
There's also a link to a draft manual, which is being updated when needed. So,
yeah. Excuse me. What is the equipment for a managed battery? want to add to a bunch of lead batteries? Well, typically, I would not recommend lead acid batteries for systems like this. The main reason is that the efficiency of lead acid is far too low. That means, especially when the battery is almost charged to 100%, the losses is extreme. That makes the whole business case go out of the window. So you need to go for lithium if you want to have a business case. And then, as said earlier, if you have a managed battery, so you can connect that with a digital cable, with a CAN cable, then the system can automatically import state of charge, levels of discharge, charge voltage, and so on. So basically, looking at efficiency, but also investment, and also the simplicity of the installation, you should go for managed lithium batteries.
I see Martin Hack tested the Node Red version of Dynamic ESS. The battery was empty on the end of the day. I think the system was looking only for data of that day, not, for example, for the next 12 or 24 hours. How will it be in the new version? Well, the VRM version, but also the current Node Red version looks ahead 24 hours, at least at 12 o'clock at night. Then it knows to look 24 hours in advance. As soon as the new prices get in, it looks farther, because then it knows the pricing for the next day. So that's up to 33 hours, I suppose, something like that.
Yeah.
Perhaps when you were testing it, there could have been a bug in it. Also for the Node Red version, and there's the GitHub issues. Please report it there if you have some anomalies. We tested on a lot of systems, but not on every system. And neither then we'll fix it.
It should work pretty good at the moment.
Yeah. If the data is from NSOE, does that mean it will not work in the UK because of Brexit and withdrawal of the transparency platform? As far as I know,
you have economy 7, so
Yeah.
you have to have fixed prices, I guess.
Yeah.
So you have the tariffs set as a fixed value per day, weekend, and so on. So then you don't need to import the values of NSOE, I guess. But
we were thinking on a more dynamic version as well, on getting but that will probably be in the Node Red version for advanced. But that's not in the UK. I think you can use the fixed prices. Can we use it when charged to boat to get the best price? When charged to boat to get a price to load?
Well, that's basically the same as an EV, I would say. That control of when to charge your boat, in this case, or your EV, is not implemented in the system yet. That may come, but at the moment, it doesn't do that. So it's just a uncontrolled thing.
Do I need an external electricity meter for my multiplus when I'm already using external current sensors? Is there an advantage to use electricity meter?
Yes, I would say so. Yeah, energy meter is more accurate and will give you also 3-phase systems readout and so on. So I would advise you to go for the energy meter in your system.
Is it possible to use live prices from utility grid provider? I'm not sure if I'm not aware if there are live prices changing. So
what I found out when doing this is that you have a number of energy providers per country. In the Netherlands, we have Tibber, we have ANWB, we have a lot of them, but all they have is a sort of a fixed formula on how their price structure is built up. And
they all use the same back-end data for their day-ahead prices, which is NSOE. And if there are systems we are unaware of, please report them in the community. Then we can perhaps add them. But report as much information as possible. including APIs where we can get the information from would be certainly be helpful. India not supported. Well, if you have fixed tariff, then it is supported.
Yeah.
Does the EV charger get a role in this as well, or does this only work with the sun surplus? Yeah, we are thinking on adding EV chargers in it, but at the moment it's not there yet.
What we didn't explain well, I realize now, is that if you have a communication from your PV inverter in your system, so if you have a Fronier or an SMA, which can communicate also with the servo, the Dynamic ESS can also control the output of that PV inverter. That means if you don't want to do anything with that energy, because, well, it will theoretically cost you money to feed in and your battery's full, then automatically we can also throttle down that PV inverter. So it's also actively controlling on that side.
Yeah. I thought you.
Somebody's already typing.
Yeah, somebody's already answering. How do you calculate battery costs? Well, we have some. Yeah, well, Johannes
there was a
already.
slide.
Yeah, already had a slide for it.
But that is a hard one, of course. It's not a, yeah.
But it's typically somewhere between 3 and 6 cents per kilowatt hour, I suppose.
Yeah.
Yeah. But it changes. Yeah, it differs per system.
Yeah.
What is the equipment for a managed battery? You want to add to a bunch of. Oh, yeah, we already answered that one.
Thank you, just what I want.
Oh yeah, what about price plafond and soldering in the algorithm? That's yeah, well, the Dutch government really makes it hard to make a good calculation. The price plafond and are not accounted for. No.
That's also a very hard one to do, because then you have to have, well, a calculation over time of amount of energy per month or whatever. So that's yeah, theoretically everything is possible, but it's not in the system at the moment.
And I think the price plafond is going to disappear next year probably. So
yeah, it's a temporary thing also.
Any plans for Ethernet connected 100 amp meter single phase?
Well, there will be a different energy meter from Victron Energy itself, and that will also run on Ethernet and also on a CAN connection. So there will be an update also on the energy meters later this year.
What will happen if the prices are not available at 3 o'clock? Well, we'll be polling the price afterwards. The system still knows the prices for the current day, so it has until 12 o'clock in the evening as forecasted or as predicted data. So it can still function until 12 o'clock, and it schedules 4 hours in advance. If you don't get the system, the new information by the end of the day, the system will run out of its schedule, and then it will stop.
It's not able to make a plan, so then it's stopped.
Then it stops automatically.
So. Will it work on a Freenet GX or only on the servo?
Yeah, it's a GX device, so it will work.
So also on Ekrano, also on other GX devices.
I'm stuck in the beta version on a battery tab. Oh, I lost the question. Well, please report if you are stuck somewhere in the. Please report that in community. Then we can. I'm sure we can fix that.
No, zie je nog één?
Any pointers on feeding in my own half-hour price information with Node-RED? No, at the moment that's not possible to feed in your own price information. It probably will be added later on, but the API does not support our VRM API does not support adding your own pricing for now. Yeah, I think.
Well, I think we should wrap it up. This presentation, so this webinar is recorded, so we will place it also on YouTube later on. So for the people who want to, well, look at it at another time or review it again. Thank you for well, being present at our webinar. And like Jan said, if there are any questions, well, go to the community also, because well, a lot of answers also can be found there. And yeah, try to yeah, help us make things better.
Yep.
Yep.
Thank you.
So thank you very much.